Hello friends, welcome to engineering tutorial. So this is the second question that we are going to discuss related to diode connections. Again we are taking a simple circuit. Here we have a silicon diode which is connected in the direction which you see, N end, P end, 5 volt DC voltage source and a 100 ohm resistor. And it has been asked to find this current I and the voltage drop across this 100 ohm resistor. Okay, like in all diode circuits, the first most important thing to do, find the state of the diode, whether the diode is on or off. And like we did in the previous question, we have two options, two ways in which we can do it. Again we'll go to both the methods we'll use for your better understanding. First method, we will open circuit the diode. So we'll assume that the diode is off. We will open circuit it. And we'll try to find out the voltage across the diode. Now the reason here I have chosen this end as a positive and this end as a negative, because a diode to be forward biased, its N end should be connected to the negative polarity, P end should be connected to the positive polarity. This the P end, this is the N end. Here P positive, N negative, that's why. Okay, so this is the 100 ohm resistor. Now as we have assumed the diode is open circuit is off, 0 ampere current will flow. So the voltage can be determined as 5 plus Vd minus 100 into 0 ampere current is equal to 0, KVL equation, or that implies Vd is equal to minus 5 volt. Vd is equal to minus 5 volt, it's in the negative. The barrier potential for silicon diode, another important thing, the forward potential, the barrier potential, the built-in potential for a silicon diode to be turned on is 0.7 volt. For germanium it's 0.3 volt. Here it is nowhere close to this, it is in the negative. Okay, it's not even in the lower positives, no, it's in the negative. So no way that this diode can be turned on in this situation. So this diode is off. Minus 5 volt is very less as compared to 0.7 volt. So the diode is off because the voltage across the diode is very low and is not sufficient to turn the diode on. Diode is off and it will always remain in open circuit mode. This is the condition of the circuit. So this current I is equal to 0 ampere. As 0 ampere current is flowing, V, the voltage drop across the 100 ohm resistor, will also be 0 volt. This is the first method. Now we'll see the second method. Okay. In the second method, we'll assume that the diode is on. Okay, we'll assume that the diode is on. Okay, 5 volt, and it is in this way. just for your understanding I am doing this, because just by looking at the circuit also you will know that this is 0. Just for your understanding I am doing this. Okay. Now let's say the current, it has been asked in this way, so we'll do that. So here there has been no mention about the forward resistance, so we'll only use the built-in potential. Silicon, so 0.7 volt. So I here is simply, this is 100 ohm, 5 plus 0.7 by 100. Okay, it is 5.7 by 100, which is equal to 0.057 ampere. Now you see this current, it is positive and it is flowing in this direction. It is flowing in this direction from N to P end. It is not possible for a diode that current will flow from N to P. I have already told this in the previous question also. Current can never flow from N to P for a forward bias diode. It is not possible. So if the discussion is related to the forward biasing of a diode, and in your assumption you have considered that the diode is on, the second method which is, and you see that current is flowing from N to P here in this way, this 0.7 volt, this is for P, this is for N. Current is flowing from N to P. It means our assumption is wrong. It can never happen. The diode will be off, open circuited. Okay, so this is the second method of approaching this circuit, and we see that the current is flowing from N to P, the diode, which is not possible for a forward bias diode. So the diode is off. It is open circuited. So again the same thing, as the diode is off, it is open circuited. I is 0, as I is 0, voltage across the 100 ohm resistor is also 0. So using both the approaches, the first method, the first approach and the second approach, either you replace it with the open circuit, assume that the diode is off, find the voltage drop across the diode, or using the second method you replace it with its equivalent circuit, find the current flowing through the diode, find its direction, whether it is flowing from N to P or P to N. If you find that it is from N to P, it is off. Both the ways we are getting the same result, that the diode is off. Okay, so you can use any particular method as per your choice, as per your comfort level. So this is the second question that we have discussed. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.